So we got into this. If you remember, we were talking about Chicago, Burlington, and Quincy, and the Colorado and Southern, and so we were talking about the lines that come up through Nebraska, through South Dakota, that went up to Billings, and they went to Billings because the Great Northern came in there, and of course the main line of the Northern Pacific is here, and of course the Great Northern and Northern Pacific owned the Burlington. And then the Burlington, in turn, had purchased the Colorado and Southern, which goes basically from here to Denver, down to the Colorado state line, and then into Texas, all the way to Galveston, Texas. So, but it went through these coal areas, and Northern Pacific had been using this coal for some time, and that's why they had the huge fireboxes in their engines, because they owned it. Remember, they had this checkerboard of land all across Montana, and they own the coal. They still do in some areas. Well, I found a slide. I was at a meeting in the 70s when Northern States Power was proposing. This is actually from a 35 millimeter slide from a presentation, and so they were proposing to haul coal from North Dakota to Minneapolis, Minneapolis and St. Paul, where all the power plants were, because at that time they were bringing coal in from West Virginia, Oklahoma, Illinois, Indiana, Kentucky. They were burning the bituminous coal. And they were saying, well, gee, we can get this is low sulfur coal, because of course, again, they were having to lower their sulfur emissions. And so this was as they were discussing it. And obviously they went, and Northern States Power was one of the early utilities to burn the Western coal, and it was a challenge, because it's not as many BTUs, and it's dusty and it's hard to handle, but it's low sulfur and it's low cost. So thought we'd look at the mining process, and basically this process is the same for any resource, whether you're mining coal or iron or copper or diamonds or whatever. Pretty much the same process. The geologists study the geology, and they sort of know, based on the topographic features, what's underneath generally. They drill core samples, and then they map the samples, and they have to be careful how they do that, because they kind of do they map every few hundred feet or whatever. They drill holes and map it. And I was involved with a project that in Australia where it looked like the seam ran north and south. And so they had drilled a whole bunch of holes here. Yep, it's right there. Well, it was really wide down here, but then the seam kind of went to this tapered sort of it almost looked like this. And so all of a sudden they're mining, a big wide area, and all of a sudden, oops, there's only a little bit, and they found out that the seam turned and went to the right, went east, and so they only had this much land leased. And so I remember going into a meeting with about 30 people in Brisbane, and there about half of them were lawyers. It was going to be it took a little bit to settle that mess. But anyway, they once they've mapped it and they know, then they have to clear the overburden. And the big thing about Western coal, and here's the overburden, but here's the resource. In out east, I had mentioned that I talked to this mining engineer, and he had worked in Pennsylvania and West Virginia, and he joked that in Pennsylvania you go down 80 feet and you get 3 feet of coal. Here you go down 3 feet and you get 80 feet of coal. Well, it's not quite that extreme, but it's a huge. These are huge seams of coal, because this was a kind of a swampy area for millions of years, and all that vegetation became coal. Well, then after they get done mining, basically they start reclaiming the land, and they have already taken off but before they start mining, they take off the topsoil, and so then they after they get done mining, they flatten the area out, make it look smooth, and they put the topsoil back down, and then they spread grass on it. And it basically looks similar to as the way it did before, except it's about 30 feet lower, or 40 feet, or 50 feet lower. So then the first thing they have to do when they start clearing the overburden is you have this big drill, and they we watched them drill, and then this truck with explosive, I think it was liquid TNT or whatever, shows up, and we decided to walk away at that point. I didn't want to be around it. It was a big tank truck, and they pour this tank, this liquid explosive into the hole, and they put a plug on it, and then they put a blasting cap on, and then they go down to the next one. And so here they have all these holes dug with and they're full of explosive, and then they blow a horn, and everybody has to turn off their phones and radios and everything else, and then they energize these things, and then they set them off, and it goes boom, 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 like this, and that's how they loosen the overburden. I mean, it's like a small earthquake. Well, then they can go in there with these big drag lines, and it's just like gravel then, because it's loose. And the drag line looks basically like a drag line from 100 years ago, except that it's about 50 times bigger. And it's still the same process. You got this big long boom, and the operator's here. He's got a cable here that pulls the bucket. And so he just lets this cable go, and this thing swings way out there. He drops it, and he gets material, and then he drags it back towards the cab. He turns the whole unit and dumps it. And you keep doing that all day, and you can move a lot of material. When we first drove up to this thing, I thought, oh, there's a crane. That's interesting. And then all of a sudden I looked, and oh, that's a truck. So I realized this thing is kind of big. It's huge. And so here we're standing here, and it's working away. And these are the guys from NSP, and there were two ladies who were the mining engineers, really smart, and they were telling us the whole process and everything. They gave us a tour, and so here's the bucket he uses. It's like a small house, and so he pulls that thing up, and look at the chain. I mean, he dumps it, and then he pulls it up and dumps it again. And so to get on board, it's just like going into a building. The thing is,
that thing's bigger than my apartment building, man.
Yeah, it is. And so we said, well, how do they move it? Well, there's these shoes, just like a steam engine. There's this big thing. This turns very slowly. It pushes this down, and then it moves the shoe like this, and then it raises the shoe again. And so you can see here it was over here. Then it moves one length, and then another length, and then another length, and then another length, and so it moves about, I don't know, is that 4 feet? And of course they have the area flat for it, but when they set that 1,000,000 pounds on it, it gets pretty hard. It's very impressive, and they move that thing around. So here's the operator in the cab. He's swinging the bucket out, and then he drops it down, pulls it, and then he dumps it. He turned the whole crane, and then he dumped it. And so he's taking area overburden from over here, and then dumping it over there. And so after a while, he's down to coal. And then they have to go and repeat the drilling process again. They drill holes, fill them with explosive. The explosive tank truck comes over, and then they put blasting caps on, and they blast the coal, because they have to loosen the coal. It can be pretty hard. And once they loosen it, then they can go in with a shovel or a front end loader or something like that. So here's they call this mine a truck and shovel. And then there's other types, like this one has a smaller thing with and they use like scrapers. And here they're using front end loader, big, huge front end loaders, Michigan front end loaders. And I've seen Michigan front end loaders, but I never seen one like this, where here's the tire, and so we're standing there, and these things, they can pick up, several tons of coal every time they move, and they move pretty fast, and they just pick it up, and then they bring it over here, and then they dump it in this hopper, and the hopper grinds it up a little bit just to make sure they get rid of the big chunks, and then distribute it on a conveyor belt. This particular mine didn't use big trucks. They used they had a less long conveyor belt, and the thing sits on crawlers, so they can move it around. Every few hours they move it, and then there was like a mile of conveyor belt. You can run these conveyor belts quite a ways, and so it runs. They have mined this area, and they're going to mine this area over here. Now this is an area where the big crane has dug all this out, and now they have all this coal, and so they're starting to work with a smaller shovel to pick up the coal. But you can see they can and this is probably 30, 40, 50 feet deep, as opposed to the seams out east, which can be 6, 8, 10 feet deep. So that's why it's pretty low cost and pretty consistent too. There's not a lot of the ash is 5, 6, 7, 8%, but 10% sometimes, but it's pretty consistent. And so it's about, but again, it's about 8,500, 8,800 BTUs per pound, whereas the bituminous coal is about 12,000. So it's only about 2/3 of the BTUs, but it's about 1/5 to 1/10 of the sulfur. And then of course the mercury is less, other minerals are less, so it's much cleaner, and it's about 1/4 of the cost at the mine. It's pretty reasonable. Here they're using some kind of a machine to fill the scrapers, and they have these coal loaders, and they have an engine in front and an engine in back and 8 tires, and they can haul 100 and something tons coal in that thing.
Wow.
Yeah, and so here's
stuff.
Yeah, it is. And that's what they have to do, because they move a lot of coal. Here's a big shovel, and this is a 250-ton dump truck, and it has a General Motors 645 cubic inch diesel locomotive engine in front and a generator, and it has traction motors on each tire, because you drive and squeezing tires, it's much more resistance than you get with moving a coal car, so it has to have a lot of horsepower.
So that's a GP40 on rubber tires.
Yeah, GP40 on rubber tires. That's what it is. Yeah. And so here's the bucket on the coal shovel. It's pretty good size, so they can move a lot of material. And so he filled this thing, and then the driver backed this thing up just very expertly, and then headed up towards the front way, and it's here she is in the cab. She's about 35. She's been doing this for about 15 years. The mine manager told us that she's the finest driver he's ever seen. She operates the equipment. It's very smooth. She has the least amount of maintenance on her stuff. And she also trains the other drivers. She just is a natural. And so she drove this thing up there, and then she comes over here and backs it up and dumps the 250 tons of coal into this hopper, and then it distributes it on a conveyor belt. And then he waved her over, and she came over and talked to us. She's quite an interesting woman, but she loves doing it. She absolutely loves it. But this thing is where she dumps the coal. Then it has to distribute it on the conveyor belt that goes up to the place where they store it, and then also to the train loading. Now you'll notice a dust collector. That's one problem with the Western coal. It breaks up easily, very friable, and so there's a lot of dust. And so that you can see these pipes are sucking. They have hoods over everything down here, and they're sucking air, and it goes into this dust collector that has filter bags, just like a vacuum cleaner. And then it collects the dust on the outside, and then they shake them, and then it falls down, and then they put it back on the belt. But here they have a coal barn to store it, because sometimes it rains and the stuff gets really weird when it rains, so they want to keep it dry. So when a train comes, they want to be able to put the coal in the train. That's the big thing they want to be able to do.